Hello, and welcome back to another speedrun. I don't know at this point what speedrun of the day it is, but in this speedrun, we are going to be covering some more complex rational functions, especially where the denominators are either quadratic functions or radical functions. So let's dive right in. So, if you watch my previous two speedruns, you know everything really you need to know about radical functions and about rational functions and about quadratic functions. And so you'll be ready with all the tools to solve some of these questions. So the questions here are simply to find the domain and range, to find the, oh, it's gone, to find the domain and range of the, find the domain of the functions. And state the equation of any asymptotes. Okay, so the first function is y is equal to 4 over x squared minus 3x. Okay, so to find the domain of this function, we need to actually factor out x squared minus 3x. And it's just that whenever the denominator is 0, the domain will be exclusive of that value. So x squared minus 3x is equal to x times x minus 3. So when x is equal to 0, in this case x will be 0 and the entire denominator will be 0, or x is equal to 3, in this case x minus 3 will be 0 and the denominator will be 0, we will have our two asymptotes there. So the domain of the function will simply be x is any real number, and x is not equal to 0, and x is not equal to 3. So that was a pretty simple domain. And to graphically confirm this, the graph of this function would look something like, let's think, for x minus 3x, I would normally assume, yeah, this function would look something like this. And as you can see, we have our asymptote for x at x equals 0. And we have another asymptote for x at x is equal to 3. Note that there would be a y asymptote. I'm not too sure where it would be, but it's irrelevant for this question. So our next function would be y is equal to 1 divided by x squared plus 2x minus 3. Negative 1 over x squared plus 2x minus 3. Find the domain, as usual. So let's factor this out. This would be equal to negative 1 over x plus 3, x minus 1. And so, of course, the domain would be when, of course, x is a real number, and x is not equal to negative 3. Since if x equals negative 3, this would be 0, causing the entire denominator to be 0. And also when x is not equal to not equal to 1. So when x is not equal to 1, when x is equal to 1, that denominator would be 0. So of course you have your vertical asymptotes at x equals negative 3 and x equals 1. It's weird that they don't ask us to find the range, but I guess it might be a bit complex. No, it wouldn't be complex at all. It would just be when y is not equal to 0 in the case of this equation. So yeah, your asymptotes would be x equals not equal to negative 3, x is not equal to negative 1, and if you want to count it, y is not equal to 0. Okay, moving on to the next one. We have the question y is equal to negative 1 over 2x squared plus 9x minus 18. Okay, what would u be equal to? So plus 9x minus 18 is a bit of an interesting one, but yeah, okay, so this would factor out to 1 over 2x minus 3 times x plus 6, I believe. Yeah. And so our domain would be when x is part of the real number set and x is not equal to 3 over 2, since when x is equal to 3 over 2, 2x minus 3 is 0, and we don't want that. And also, x is not equal to minus 6, since when x is minus 6 plus 6 is 0, so that would be 0. Of course, the other asymptote would be y is equal to 0, so the asymptotes would be x is equal to 3 over 2, y is equal to 0, and x is equal to 6, negative 6. So yeah, pretty standard problem, and let's go to the final problem of this exercise. So the final problem is y is equal to 1 over the square root of 2x squared minus 3x minus 2. And so this would, of course, be equal to 1 over the square root of x minus 2 times 2x plus 1. And so this is a bit more of a complex function, you see? Because the function will only be available if x minus 2 times 2x plus 1 is greater than 0. Since if it's equal to 0, the function, you can't divide by 0, and if it's less than 0, you can't take the square root of a number that's less than 0. So let's find the values for which this is true. This looks simply to be x is greater than 2 or x is less than negative 1/2. So if x is greater than 2, that means both x minus 2 and 2x plus 1 are positive, so it would be greater than 0. And if x is less than 1/2, it means that x minus 2 and 2x plus 1 would both be negative, so the overall resulting number would be positive. So that would be the domain of this function. Any asymptotes would be, I guess, x is equal to 2 and x is equal to negative 1/2. The values for which this would be less than 0 wouldn't be asymptotes because the graph would never tend to them. And finally, of course, y equals 0 would always be an asymptote. So there we go. That's it for the 4th speedrun of today, and I hope to catch you in the next speedrun. See you then.